In this lesson, we'll discuss how to access databases in Java using the API known as JDBC. In the last lesson, we mentioned that all DBMS use the client-server architecture, and programs like Java applications are database clients, just like MySQL Workbench. The way they work is that they use a library to send SQL and other commands to the database server. And the same library is also responsible for getting the results from the server back to the client. The library that connects Java programs to databases is known as JDBC, which stands for Java Database Connectivity. The nice thing about JDBC is that it splits the library into two parts: the JDBC API, which is DBMS independent, and the implementation of the JDBC API, which is usually called a JDBC driver. The benefit of doing this is that your code only depends on the JDBC API, so it's not tied to any specific DBMS. For example, if you want to use MySQL, just include a MySQL JDBC driver jar file, and later if you want to switch to a different DBMS, for example Postgres, simply replace the MySQL jar file with a Postgres jar file, and your Java code needs very little change or even no change at all. This is a pretty significant advantage comparing to some other languages like PHP, where if you want to switch DBMS, you'll need to change all the database function calls in your code. Now let's look at an example and see how we can use JDBC in our code. In this example, I have a database table called items, and I want to display the content of the table. Let me quickly connect to my database and show you the table. So my database is on my local computer, and I'm using the username CS320STU31, and the database name is also CS320STU31. The -p option tells MySQL client that I want to enter a password. And these are my tables, and this is the content of the items table. I have a couple of records there and a few attributes for each record. So in this code, I want to display the content of this table in a servlet. And let's run this code and see how it works. And they simply just display the content of the table. Now, let's go over the code, and I want to discuss a few important things here. First, notice that we need to load the JDBC driver class first. This only needs to be done once for our application, so we can do it in the init method of one of the servlets in the application. And then we need to connect to the database, which is here. We need to make a connection to the database. Remember, in the last lesson we said that to connect to a database, you'll need to know a few things. You'll need to know the host, port number, username, password, and the name of the database. All those information are here. Please pay special attention to the URL of the database. Notice that it has the same format as a web URL. You have the protocol, and then the host, and then the optional port number, and then the path. And the path here is the database name. In a web URL, the protocol would be HTTP, and here JDBC is the main protocol and MySQL is called a sub-protocol. And because the port number 3306 is the default port number for MySQL protocol, we don't need to specify the port number here. Now, once we have this information, we can create a connection and simply call driver manager get connection, give the URL, username, password, and that's it. And then we can create a statement from the connection, and then we can call the execute query method to run a query. The result processing part needs a little bit explanation. When we run a SQL query, the results come back as a table like this. So what do we want to do with these results? Well, we would want to access each record in the table. And for each record, we would like to access each attribute. And sometimes we may also want to get the column names of the table. And let's see how we can do that. Imagine that these are the results stored in a ResultSet object, or this one. And imagine that there's a pointer or a cursor that points at the position before the first record in the results. Whenever we call the method ResultSet.next, this cursor moves down one row. So for example, the first next method call would move the cursor from the position before the first record to the first record. If that row currently pointed by this cursor contains a valid result, the next method would return true. Otherwise, it will return false. So imagine that we keep calling the next method, next, 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 and then next. So the cursor will go through each result, and after the last result, next will return false, and then we know there's no more result. And this is basically how we access each record in the results. We just go over them one by one by calling the next method. And because this is how ResultSet works, these are the code commonly used for processing results. We would use a while loop to access each result, or if we just want to check if a result set is empty, or if we know for sure there's at most one result, we can just use an if statement. Here in my example, I'm using a while loop because I know that there are likely more than one record in the results. Now, to access the attributes of a result, we use those getSomething methods like getString, getFloat, getDouble, and so on. Here, I'm using getString for the first two attributes, and then getFloat for the quantity column. We can either get the value by column name, like getStringUser or getStringName, or we can get the value by column index. Note that column index starts from 1, not 0. Most of the time, we would already know the column names, but if necessary, we can also get the column names dynamically in code using ResultSet metadata. There are couple of methods in ResultSet metadata you can use to get the column name or column label just by specifying the column index. For MySQL, getColumnName and getColumnLabel return the same thing. For some other DBMS, column name may be the original name, and column name label could be the column alias. Another thing I want to mention is about the size of a result set. If you read the API documentation of ResultSet, you'll notice that it doesn't have a size method. This is because databases are designed to manage lots of data, and sometimes the results are so large that they don't fit in memory. So ResultSet is not implemented as a regular Java list, so there's no size method there. Instead, it only loads a fixed number of results in memory, and that fixed number is the fetch size mentioned in the API documentation. Remember that application goes through the results one by one. So when it exhausts the results currently in memory, the JDBC driver will load the next batch from the database. And this is the reason why there's no size method in ResultSet. And to get the size of a result set, you'll have to do a separate count query. The last thing about this example is exception handling. When you work with a database, there could be lots of exceptions. For example, when you try to load the JDBC driver, the driver may not be in the class path. When you try to connect, there could be errors in your username password or the database name. And when you run queries, there could be syntax errors in your query string and so on. So Java requires that you either catch those exceptions or declare them. My take on exception handling is that if you can recover from an exception, then catch it. Otherwise, just declare it and let somebody else handle it. In this example, however, if there is a database error, there's really nothing we can do about it in code. So normally, I would simply declare the exception, and because there's no point catching it. However, in this example, we have to override init and the doGet method. And if, for example, instead of catching the exception, we declare an exception class not found exception or something here, that would change the signature of the method. So we wouldn't be overriding init, or we wouldn't overriding doGet. So we cannot simply declare the exception here, and we have to catch it. So what we do here is that we catch the exception, but since there's really nothing we can do about it, we simply repackage this exception into a servlet exception and then throw it again. And this is called a rethrow. So in init, we catch class not found and then rethrow it as a servlet exception. And similarly, in doGet, we catch the SQL exception and rethrow it as a servlet exception. One thing related to exception handling is closing the database connection. This is very important because each account typically has a fixed number of concurrent connections allowed to a database. For example, on CA3, each account has a maximum number of 5 concurrent connections. If you don't close database connections properly, you'll soon run into the too many connections problem. And this is why here we close the connection in the finally block. This is to make sure that the connection is closed even when there's an exception. Okay, now that we know all the basics, let's go back to the guestbook example. And this time we'll add database to the mix. I already have the MVC version of the guestbook example running here. This is again the guestbook entry model class, ID name message, and I have the display code here, which creates two guestbook entries in the init methods and then do the display, and it shows the two entries here, and we can add comment hi, and add comment is here. It in the do get it shows a form, and in do post it creates a new guestbook entry from the user input, and then add that entry to the list of entries stored in the application scope. So let's see that how we can do this using a database. Let me stop the server first. Well, the first thing we do is that instead of using application scope to store the data, we are going to use a database. So let me quickly create a database. So I'll call this guestbook SQL, and we'll create a table to store our database, our guestbook entries. And the guestbook entries has three fields: ID, name, message, and they are all simple Java types, numbers and strings. And that means this class can be directly converted into a table. So we'll do that, and we'll say job table if exists guestbook, and I'll create a table called guestbook, and it will have an ID field, integer auto increment, and primary key, and it will have a name field. I'll do varchar 255. It will have a message field, and the message can be pretty long, so let's do at least varchar 8000, and that's it. Okay, notice that I'm calling it guestbook. I know that I said SQL naming conventions usually use plural form for tables, but guestbook kind of implies that it has a plural number of entries in it. So I'm just going to call it guestbook instead of guestbook entries or whatever. Okay, so let me run this, and we'll do source guestbook SQL, and it shows it creates a guestbook table. Oh, nothing in there yet. Let's create a couple of entries. We'll do insert into guestbook, and I'll let the system to generate the ID. So I'll specify name and message, and the values. The first one is John, hello, Joe, hi. Okay, the first one is John and hello, and the second one is Joe and hi. Okay, so let's run this one again. Okay, now we have our tables. So we look at our previous code, and do I have the ID? Yes, we have the ID. We look at the previous code, and the model class still looks very much okay. So we'll keep the model class. And just like our previous development process, we look at a web application and we consider the data and operations. And data, we have the Java representation, we have the database representation, so data is okay. And for operations, we look at the display first. So we look at the current code, and the current code stores data in application scope. Now we no longer need that because the data is now in database. So let's get rid of all this code. And let's copy over the driver initialization code to here. This part will load the JDBC driver, and that's that. Now, in the previous code, I simply forward to the view, and that's the guestbook.jsp, and this view used to get entries from application scope and display them. Now, again, the data is no longer in application scope, so we have to retrieve the data from the database first. And let's do that. Again, I'm going to copy over some code from here. And okay, that's quite a bunch of code. And I could put it into get. Do I want to put it into get? Yeah, let's just put it into get. Okay, so here, instead of trying to do display directly, we want to create a list of entries just like before, and then we pass that list of entries to the view for the view to display. So what we'll do is we'll say guestbook entry and entries, and let's create a list of entries. And here the database is the same, and driver statement result set. Here it will say select star from guest book. And now in the while loop, what we'll do is we'll create a guestbook entry, new guestbook entry. No. Is it? Yes, it is. And new guestbook entry, we need ID, we need name, we need message. So we'll have rs get int ID. Is there a get integer? No, just get int. And then rs get string name, and then rs get string message. This would create a new guestbook entry, and then we add this new guestbook entry to the entry list, and we catch exception, we close connection, we do all that, and at the end, so hopefully after all this work, now the entry list is populated with guestbook entries retrieved from the database, and then we need to pass it to the view. So we do request set attribute entries, and then entries. So that should do it. And let's run this and make sure it works. No, not this one. Guestbook. Okay, it says John, hello, Joe, hi. and just make sure it's actually getting the data from the database. So let's change the message in the database. So let's say update guestbook set message to be hi there, where ID is 2. We do a refresh, it says hi there, and this tells us that it's indeed getting the data from the database. Okay, so let's look at this example one more time. And this is not a complex example, but it's again very representative of how to do database-backed MVC application. So notice that it's still very much an MVC application. We still have the model class, we still have the controller, we still have the view. And the only difference here compared to what we did before is that the data now comes from database instead of from application scope, but everything else is still the same. In particular, notice this part of the code. So in your Java code, it's very typical that you will have some type of translation code that basically translates the rows and columns in your database into objects and object fields in your object-oriented language. So here basically we are taking each row in the result, and we convert that row into an entry object, and for each column in the row we convert that into a field in the entry object, and then the rest of the code is still the same as before. And this is very typical of how MVC application uses a database. You simply have some code to convert data from relational to objects, and then later on when you do when you try to save the data, you convert the objects into rows and columns. Okay, so this is the display operation, and then let's look at the add operation. So here we have our add comment, and so in the do-get part, it displays add form, and this is a view, and it should remain the same, obviously. And this part needs to be changed. So instead of creating a guestbook entry and add it to a list in application scope, here we have to save it in database. So we still need to get the user input here, but the rest of this needs to be replaced. And let's grab the code here. And we create a connection, same database, and instead of saying execute query, now we have to say execute update. So what are we trying to update? Let's create the SQL first. So the SQL would be something like this. We'll do insert into guestbook, and we'll say insert the name and message, let the system to generate the ID, and name, message, values, and then we need to specify the name. So strings in SQL are enclosed in single quotes, so we do a single quote here, we do class name, and then we pass another single quote, and then comma, another single quote, and then class message, plus yet another single quote, and then parentheses. So insert into guestbook values this and that. Okay, so this would be our statement, and to run that statement, we'll say execute update. and that will be this one. And then there's no result since we are running an insert. The rest of it still need to be there, and then after that we send a redirect. Okay, so let's see if this thing works. And restart and refresh. We add comment. We'll say CYSOM says hi. It shows up here, and if we check the database, it says CYSOM says hi. So this definitely works. So there are there's one thing I want to mention. Well, there are a couple of things, but first things first. So first of all, this is the way we can do an insert. We create the SQL string, and just like before, except that previously the string is pretty simple, and here it's slightly complicated because we need to add the name and message to it. And then we can run that SQL statement using execute update and instead of execute query. The reason we have to use two different method calls to run SQL statements is that the query statements or the selections have different return values than those update statements like insert, delete, and update. A select statement would return a list of results, or in other words, a table, and that in Java has this type result set. For update statements like insert, deletes, and updates, they don't return a table. They typically return an integer, and that integer tells us how many rows are affected by that update statement. And so in Java, the integer obviously is a different data type than result set. So in Java, they have to use two different methods to run those SQL statements. And for update statements, this is the method execute update. Now this works to an extent, but if we want to add something else, it may give us some problems. So let's say that I want to leave a message. I want to say it's a great site, and all of a sudden we get an exception. And if we look at the exception, it says something about SQL syntax and this and that. And the problem near the single quote, right? And we look at the string we try to enter, we notice that there's a single quote there, and that tells us that the reason we got an error is because that single quote seems to mess up our SQL statement. That's because if we add in the single quote, the constructed statement becomes something like insert into so the constructed statement looks like this. Now, with no special characters, if we put the name here, the message here, then everything will be great. However, if there's a special character in particular, if there's a single quote there, it becomes CY song, and it's a great site, and notice that it becomes a string itself, and the rest of it becomes something outside the string, and that of course will lead to a syntax error in SQL. And this shows us that we have to be very careful about special characters. In fact, this type of mishandling of special characters can lead to something more serious than a simple exception. It could lead to a very well-known website attack called SQL injection attack. SQL injection attack happens when a malicious user tries to enter some input in your web application that you don't expect, and that input happens to lead to a SQL statement that can harm your web application. So let's look at an example of a so-called SQL injection attack. And I have the code already in here, and let me first run the code and show you what the code is supposed to do, and then we'll see how to attack it. So in my database, I have a table called employees. And in this table, I have employee username, password, and then some private information about the employee, for example, birthday and salary. And suppose we want to create a web application that lets the employees to see their own information, but obviously not other employees' information, due to privacy issues and so on. So what we do is we can create a web application like this and ask an employee to type in their username and password. And for example, if I'm employee John and I know my username, which is John, and my password is ABC, and I can see my own information. Now, if I try to see somebody else's information, for example, Jane, and I don't know Jane's password, and I won't be able to see anything. Now, it seems to be working, but if we look at the code, we can see that it's not a secure code, and we can perform an SQL injection attack on the code. Now, the code, just like the guestbook example, is MVC. The model class is this employee class, ID, username, password, birthday, salary, corresponds to the columns in the table. There's nothing special there, just a typical POJO or model class. And then we look at the controller. The controller, the doGet part simply displays this form, and this is a form. It simply get the username and password, nothing in it, so there's nothing tricky there either. Now, the problem is in the doPost part. Now, in the doPost part, it gets the user's username and then the password, and then it tries to construct a SQL statement, just like what we did in add comment. And the way it tries to construct the SQL statement is once again using concatenation. It does a select star from employees, where username is something single quote, and then get the username from the user, password single quote, get the password from the user, and then it will do a selection. And just like in the guestbook example, it will get the results, store the results in an employee object, and then pass that object to the display part, and the display part will display the employee's ID, username, password, and so on. Now, if a user gives the wrong password, this selection query supposedly will return an empty result set, and that's why If we don't know the username password, we don't see anything here. Now, if you look at the code, everything seems to be okay, except that the way the SQL statement is constructed, it leaves room for a malicious user to attack this application. So how can we attack this application? Well, it's not all that hard. So we'll say username something something. Let's say I don't know any username. Password, well, I don't know any password either, but I do know how to trick the system. So I'll enter a password with a special character here, and then we'll say or 1 equals to 1. And if we run this, voila. Although we don't know any username and password, somehow we get all the information of all the users. So how could this happen? Well, once again, it's due to the way the SQL statement is constructed. So this is what it tries to do. It tries to get a username and put the username in a pair of braces, a pair of single quotes, and it tries to get a password, try to put it in a pair of single quotes. And what the attacker did was the attacker put something in username. It doesn't really matter what it is, so it now looks like this. And then the attacker put this one inside password. So now you'll see what's happening. So the query statement becomes username is this and password is this, or 1 is equal to 1. So since 1 of course always is equal to 1, this will be true, and since the whole condition is an OR condition, so if this is true, then the condition, the whole where clause always true, so it actually selects all the employees instead of just one of the employees. Now you can craft other type of input to lead to similar results, but this is just a simple one to trick the SQL statement to select everything instead of trying to select only the employees with matching username password. And this is an example of the very well-known SQL injection attack, and this is in fact a very widely used attack, and obviously it's quite dangerous, as you can see. Now the good thing about Java is that we can prevent SQL injection attack in a fairly simple way, and that's using the so-called prepared statement. Now, the way prepared statement works is that instead of trying to construct an SQL statement using string concatenation, you simply create an SQL statement with some placeholders with question marks. And when you actually need to put values inside the SQL statement, you use set string or set int or set whatever data type to set the actual parameters into the placeholders. So for example, this one will set the first one to be orange, second one to be 0.59, third one to be 4. So instead of manually try to create this statement using string concatenation, you let the SQL driver to help you to create that. And the good thing about that is the SQL JDBC driver knows all about special characters, and they will properly escape all the special characters so that they will be treated as either string or whatever type you specify, without generating SQL statements that you are not expecting. And this is actually very easy to do. So all we need to do is change a little bit code, and here we'll say, instead of creating something like this, we'll say let's create the SQL as insert into guestbook name. Message values is question mark and then question mark again. So we have two placeholders there. And instead of using statement, we'll use prepared statement. And so notice that there are two prepared statements, one from the MySQL library, one from the JDBC API. You would want to choose the second one, so your code is more general. And so it's no longer create statement, it's prepare statement, and prepare the SQL statement we just created. And then once we have that, to run the statement, we'll have to say p statement set, what's the syntax for that? Set string, and the first position we set it to value name, and that's what we get from the parameter of this p statement. And p statement set string again. The second one should be the message. Okay. And then to run p statement, we simply say execute update. So no longer have to say SQL. Okay. And this should do it. So if we do that, let's run this again. And the guestbook will add something. We'll say CY is a great site, and this time it works perfectly fine. And if we look at the guestbook, you can see that single quote is now in the table. So this is how we can use prepared statement, and there are many benefits of using prepared statement. Not only it properly handles special characters and prevents SQL injection attacks, it makes the SQL statement more readable in code. For example, comparing this one to this one with a bunch of string concatenation, you can see that obviously this one looks much nicer and readable. And in some cases, prepared statements may even have some performance benefits because they are pre-compiled inside the database system. So all in all, prepared statement is one of the best features in JDBC, and there's really no excuse not to use it. So in particular, anytime if your statement involves input from the user, you can never trust user input. So anytime if your SQL statement involves user input, always use prepared statement. Now, if the statement contains no user input, for example, something like this, right? There's no user input and everything is written by the developer. And for those type of statements, you can get away with not using prepared statement. But overall, try to develop the good habit of always using prepared statement for updates. And that's pretty much it. This is the end of this lesson. See you next time.